This lesson is about integration by parts. At the end of this lesson, you must be able to illustrate solutions on integration involving product of two functions using a technique called integration by parts. Let us now explain what integration by parts techniques is. Suppose that u and v are differentiable functions of u. Then the differential of the product uv is given by u dv plus v du. And that, if we are to solve for u dv, that will just be equal to the differential of uv minus v du. Evaluating the integral of u dv, that will just be equal to the integral of the differential of product uv minus the integral of v du. Recall from the definition of the integral or the antiderivative that the integral of du is just equal to u. Hence, the integral of the differential of uv will just be equal to uv. And therefore, this particular formula can be simplified to the integral of u dv is equal to uv minus the integral of v du. This particular formula here for integration is called integration by parts. The main goal here is for you to assign a factor of the integral as your u function and the rest your dv. Okay, so on the basis of the function that is easier to differentiate to be assigned u, then dv is assigned the differential that is easier to integrate. To be successful in evaluating an integral using integration by parts, we should choose accordingly what our u and dv functions are. Now, it will help us knowing that the order of priority of functions to be assigned u is as given here, that the logarithmic function has priority over the inverse trigonometric function. The trigonometric function has priority over the algebraic function, and then the algebraic function has priority over the trigonometric function, and lastly, the trigonometric function has priority over the exponential function as the function to be assigned u. The rest of the factors of the integrand should be assigned dv. Now, it will help to remember that we have this acronym representing the first letter of the terms for each of this function. Okay, this will help us remember the order of priority of functions to be assigned u. Okay, let us now illustrate the use of the technique integration by parts to evaluate some integrals. Remember, IBP or integration by parts is done following this particular formula, where the integral of u dv is equal to uv minus the integral of v du. So, when we're asked to evaluate the integral of x cosine of x dx, please take note that this would not fit a cosine u du form, nor would it fit an expression or a polynomial in x. So, this given integral here is evaluated using integration by parts. Now, we assign now what our u and dv functions are. And please take note that we have this acronym that will tell us the priority of which function to be assigned u. Here we have the factors x and cosine x. X is algebraic in nature, cosine x is trigonometric. And checking it out here, the algebraic function has priority over the trigonometric function to be assigned as u. Therefore, we have u is assigned x, then the differential du will just be equal to dx. The other factor now with dx will constitute dv, hence dv is cosine x dx, and the integral of this giving us v is just equal to sine of x. So if we are now going to evaluate the integral of x cosine of x dx using IBP, then this will just result to having x sine of x, this is your uv factor, minus the integral of v du. Now, please take note that when you have applied IBP correctly, the integral part of the right member should be easier to evaluate as compared to the original integral. And that is noted true in this case because it is easier to evaluate sine x dx. So, if you are now going to evaluate the integral of sine x dx, then the integral of x cosine of x dx will just result to having an x sine of x plus cosine of x plus c. For our second example, let us evaluate the integral of ln of x dx. Okay, again, we will be using integration by parts here because the given integral does not fit any one of the integration forms that was given, no, or that were given the class. So here, again, we have to choose u and dv, no, expressions, and we don't have any other choice here except to assign as u ln of x and the differential dx as your dv. Okay, so with that, du will be dx divided by x and v will just be equal to x. And that the integral of ln of x dx done by integration by parts is given by x ln of x, or that is product of u and v, then minus the integral of v du, or giving us x times dx divided by x. Now, this particular factor here can be simplified to just a dx, so that what we have is the expression x ln of x minus the integral of dx. Or we have for the integral x ln of x minus x plus c, the integral of ln of x dx. For our third example, let us evaluate the integral of e to the x sine of x dx. Again, using LIATE as basis for assigning what our u function is, then u would be assigned with sine x, dv would be e to the x dx, and as such, we come up with du given by cosine of x dx and v equal to e to the x. So if we are going to substitute this in the formula for integration by parts, then the integral of e to the x sine of x dx would just be equal to e to the x sine x, this is your uv product, minus the integral of v du, or the integral of e to the x cosine of x dx. Now, at this point, please take note that this particular integral is of the same nature as the original, and therefore, this is also evaluated using integration by parts. So, in this particular example, we are applying integration by parts the second time, and on this basis, our assignment for you will be cosine of x, and dv is e to the x dx. A word of precaution: when you are applying integration by parts the second time, u should not be v of the previous application, and dv should not be du of the previous application. Now, if you will follow the IATE acronym, then you will not go wrong in assigning what your u and dv, even if you are working on the second application of IBP. So with this assignment, the integral now will be given by e to the x sine of x minus the integral of this term done by IBP given by the following terms: e to the x cosine of x minus the integral of e to the x times negative sine x dx. Or you can write this as e to the x sine of x minus e to the x cosine of x, negative 1 times negative 1 times negative 1 will account for the third term of negative integral of e to the x sine of x dx. Now, at this point, we see again the integral of e to the x sine of x dx, which is the integral that we are originally evaluating. So what do we do at this point? We simply combine similar terms together, grouping this with the left member expression to give us the integral of e to the x sine of x dx to equal what is given on the right, e to the x sine x minus e to the x cosine of x plus an arbitrary constant c sub 1. To evaluate the required integral, which is the integral of e to the x sine of x dx, it is just a matter of dividing both sides of this equation by 2, so that we have the integral of e to the x sine of x dx to equal 1/2 of e to the x sine of x minus 1/2 of e to the x cosine of x plus the arbitrary constant c. In summary, integrals can be shown to fit a particular integral form, and as such can be evaluated based on the given form. However, if a particular integral fails to fit an integral form, then the way to evaluate it is by using an integration technique, one of which is integration by parts. For as long as it can be shown that the integral is in the form of u dv, then it can be evaluated on the basis of this formula. The integral of u dv is equal to uv minus the integral of v du.